objective relations and functions. Here are a few definitions. Definition number 1, a relation is a set of ordered pairs. Definition number 2, the domain. This is a set of input values. These are the x's, x values. Definition number 3 is the range. This is the set of output values. These are the y values. Definition number 4, a function is a special kind of relation. It has no x values that are repeated. No x values repeated. So each x has exactly one y, or each y has exactly one x. X's are not repeated. Definition number 5, the function rule. An equation, so a rule is an equation that describes a function. Definition number 6, function notation. So this is a way to write a function. When you use f of x or f of some variable, it could be these could be two different variables. So it could be g of x, g of h, f of y. These are two variables. F of x, this represents the output, and the inside represents the input. This indicates the outputs. If it's f of x, that's an output. The inside portion is the input. We read this as f of x. And you'll see several examples. Vic number 1, you can use the vertical line test or a mapping diagram to determine whether a relation is a function. So there are two ways to determine if a relation is a function. Vic number 2, the vertical line test, VLT, you'll see me abbreviate, vertical line test. If any vertical line passes through more than one point of the graph, then it is not a function. Vic number 3, mapping diagram. The domain, that's the x's, must all be different numbers. The range, that's the y's, can be the same number. Finding domain and range. Example number 1. So here is a set of ordered pairs. This in black is called a relation. We're going to identify the domain. So D and this colon with a curly bracket on either side represents a set of numbers. The D represents domain. So we look at the x values, 1, -4, 3, 0, and 2. These are all x values. They all belong in the domain. I've listed them in order from least to greatest. None of these values are repeated. The range, that means the y values. So 3, 0, 1, 4, and 3. Now you heard me say 3 twice. However, when I write the range, I only write each number one time, even if it's repeated. And I put them in order from least to greatest. Example number 2. This is a relation, a set of ordered pairs. All of the values, all of these are x values. So 2, -2, 2, -2, and 3. These are all x values. When I write the domain, remember you don't repeat any of them and they go in order from least to greatest. -2, 2, and 3. Even though -2 is repeated, I only write it one time, and even though 2 is repeated, I only write it one time as well. The range. The range are the y values. -3, 3, 3, -3, and -2. So I've listed them in order from least to greatest. Again, none of them are repeated. Is the relation a function? So let's look at example 1. If no x values are repeated, then it is a function. These were not repeated, so yes, the first one is a function. Example number 2, the x's -2 and -2 were repeated, and 2 and 2 were also repeated. So no, this one is not a function. It's still a relation, a set of ordered pairs, but it is not a function. Example number 3. Here I've taken the set of ordered pairs and I've created a mapping diagram. So in one bubble we put our x values, In the other bubble, we put our y values. We list our domain and our range in order from least to greatest, and you again only write each number one time, just like we do in our curly bracket sets. You draw an arrow from the x to the y. So here, 2, 3. From the x is 2, drawn an arrow to the y, that's 3. And you repeat this process, 5, negative 2, 5 to negative 2, 6 to 3, 6 to 3, and 12 to negative 12, 12 to negative 12. You can take this mapping diagram and go back to the ordered pairs. Are any of these x's repeated? Well, 2 only goes to 3, 5 only goes to negative 2, 6 only goes to 3, and 12 only goes to negative 12. None of the x's are repeated. So, yes, this is a function. Example number 4. I've gone ahead and drawn the mapping bubbles, and we're going to draw the lines now. So 3 goes to 7, 2 goes to 5, 1 goes to 6, and 3 goes to negative 5. Do you see that 3 was used twice? It went to negative 5 and to 7. So no, this is not a function. And the secret word is going to be elephant. Use the vertical line test to determine whether each graph is a function. This is a straight line. If you have the vertical line test, that means that you have a vertical line. Imagine your pencil or a marker and you're going from left to right and you move it across. If this vertical line touches the graph at more than one point anywhere on this plane, then it is not a function. I can pass this marker all the way through and it only crosses at one point each time. So yes, this is a function. In this example, as I move my marker across, right here, you can see that if I drew a vertical line, it would touch here and here. If I keep going, it's touching here and here. You see that many times a vertical line would cross the graph more than once at more than one point at the same time. So no, this is not a function. Here. All right, it's passing, passing, but when I get to this vertical line, then I can see it's touching there and there and there and there, more than one point at each time. That vertical line means that this is not a function. All right, vertical line test again. Slide your pencil all the way across the graph. This one passes the vertical line test. So yes, this is a function. Evaluating function rules. Example 5. Evaluate f of n equals negative 3n minus 10 for n equals 6. So what this means is this is an output. N equals 6 is our input. So instead of n, we're going to plug in 6 on both sides. Take n out, and put 6. So I rewrote the original function rule. Instead of n, put 6 because it says n equals 6. Instead of n, put parentheses and put 6. Just like we were checking our answers before. Remove the variable, put parentheses, and put your number inside. So, f of 6, this means what is the output when x or n is 6, when our input value is 6. So negative 3 times 6 is negative 18. Carry down negative 10. Negative 18 minus 10 more is negative 28. So when our input is 6, our output is negative 28. And we can write this as an ordered pair, like a point on a graph. 6 is our x value, our input, and negative 28 is our y value, our output. This is a point on the graph of this line, and we'll talk about that more later. Evaluate y equals negative 2x squared plus 7 for x equals negative 4. So again, I copied the function rule. Instead of x, put parentheses, and put the value of x inside. So x was -4, plug in -4. And now we're going to evaluate. Remember, our order of operations says we do exponents first. So -4 squared means -4 times -4, which is 16. So I have -2 times 16 plus 7. Now we multiply before addition, so this gives us -32. Carry down the plus 7. Now add 7. -32 plus 7 is -25. This is our y value when x is -4. So if x is -4, then y is -25. We can write it as an ordered pair. This point will be on this graph. And we'll look at that on our calculators later. Alright, last slide. Evaluate g of x equals -x plus 2 for x equals -3. Again, copy the function rule. Instead of x, put -3. Take the x out, put -3 in. You do the same thing to both sides of the equation, just like always. Take the x out, put the -3 in. Notice that negative was already there. I don't change it. So a negative times a negative is a positive. Plus 2. 3 plus 2 is 5. So when x is -3, y is 5. And you can write it as an ordered pair. -3, 5 is a point on the graph of g of x equals -x plus 2. Two more examples. Find the range of each function for the domain. So here's the domain, -2, 0, and 5. These are three different x values that we're going to plug into our function. Here's our function rule. If x is -2, so I take x out, I put -2 in. Where x was, I put -2. -2 minus 6 is -8. So that's one value for my range. It says find the range. If x is 0, f of 0 means if x is 0, what is y? Take x out of the original, put in 0. So take x out, put in 0. 0 minus 6, -6. And let's do the same thing for 5. If x is 5, if the domain is 5, what is the range? Take 5, plug it in where x was, on both sides. Take x out, put 5 in. 5 minus 6 is -1. So -8, -6, and -1 are the range if the domain is -2, 0, and 5. And our last one, we have g of c equals c squared plus 1. If g is -2, what is c? So what we're going to do, or what is g of c? So what we're going to do is take c out and put -2 in its spot. Now notice -2 was squared, or c was squared, so -2 will be squared. -2 squared is 4, plus 1 is 5. Do the same thing for 0. Take c out, put in 0, it gets squared, plus 1. 0 squared is 0, plus 1 is 1. Take out the c and put in 5. 5 squared, plus 1. 5 squared is 25, plus 1 is 26. So I have 1, 5, and 26 for my range, and I put them in order from least to greatest. Thank you.